So we have an orbit question where we're looking at the Sun and the Earth. The first question asks us to indicate the direction of the acceleration of the Earth in this Sun-Earth system. So if I draw the Earth over here in green, the direction of the acceleration is going to be in the direction of the force. Now the force is always towards the center of our circle, or towards the Sun, because the Sun is the object applying the force to the Earth. So our direction of our acceleration is inwards towards the Sun, which makes sense because in circular motion it is always perpendicular to the velocity, which is at a tangent to our circle. So we have right angles there. So that's question 1 done. Second question, we need to find the mass of the Sun, and we're given the gravitational constant. So if we write down some formulas which have masses for gravity, we have force equals a gravitational constant times the mass of the Sun times the mass of the Earth over the radius squared. We also know that the force is equal to 4 pi squared times the radius times the mass of the Earth over the period squared. Now, because we have both the mass of the Earth at the top here in both equations, we can make those equations equal to each other and cancel out the mass of the Earth, which we don't know because we're not given it. So if we do that, we get gm of the Sun times the mass of the Earth over the radius squared equals 4 pi squared r mass of the Earth over the period squared. Now these cancel out, which leaves us with just the gravitational constant and the mass of the Sun on the left hand side over the radius squared, which we want to then move over to the other side. So we can do that by multiplying by r squared and dividing by the gravitational constant, which leaves us with the mass of the Sun being equal to our right hand side. From here, it's just a matter of substituting in values. So the values that we know are the gravitational constant, which is given to us, 6.67 times 10 to the negative 11. The radius, which again is given in the question as 1.5 times 10 to the 11 meters. And we know what the period is because we live on the Earth, which is 365 days, give or take a little bit. And then multiplied by 24 hours, by 60 minutes, by 60 seconds, gives us a period of 31536,000 seconds, or 3.1536 times 10 to the 7 seconds. So putting these values in, we're going to get the mass of the Sun, which is what we want to find, is equal to 4 pi squared times the radius, 1.5 times 10 to the 11 cubed, over the gravitational constant, 6.67 times 10 to the negative 11, times the period squared, which is 3.1536 times 10 to the 7, and that is squared. Putting those values into a calculator, you should end up getting 1.33 times 10 to the 35 on the top, and 6.63 times 10 to the 4 on the bottom. And 1 over the other gives us the mass of the Sun, which is 2.0 times 10 to the 30 kilograms, rounded off to 2 significant figures because the radius was given to 2 significant figures. Hence we have our answer for the mass of the Sun by using 2 different equations, cancelling out the variables we didn't know, and then substituting in the variables we did know to find our answer.